supervolcano that is a continent killer, and it blows every 600,000 to 800,000 years, and everyone dies.
Chopper 5 is giving us our most complete view of the flooding inside Yellowstone National Park.
Imagine standing on the edge of a bubbling, steaming cauldron of geological wonder, where the earth shifts and trembles beneath your feet. Well, that's exactly what's been happening in Yellowstone lately. The recent surge in seismic activity is unlike anything we've seen in decades. It's a sobering reminder of the raw power and unpredictability of Mother Nature. So what's causing this seismic stir? Could it be a prelude to a tragic event? Join us as we unravel how a Yellowstone official recently gave a serious warning after hundreds of quakes hit the national park. Yellowstone, where nature's majesty meets history. Yellowstone National Park sits proudly in the western United States, spreading its beauty across the northwest corner of Wyoming, reaching into Montana and Idaho. This vast park is famous for two things: its incredible wildlife and its amazing geothermal features. Among these natural wonders, the Old Faithful geyser stands tall as a crowd favorite, captivating visitors with its regular and powerful eruptions. While Yellowstone showcases various ecosystems, the subalpine forest reigns supreme, blanketing much of the park's landscape. Yellowstone's diverse habitats and amazing geological features draw in adventurers, nature enthusiasts, and scientists, making it a beloved gem of nature. In the ancient days, long before Yellowstone earned its title as a national park, it was home to numerous Native American tribes. Among them were the Crow, Shoshone, and Blackfeet, who not only dwelled in these lands, but also regarded them as sacred. Although much of their history remains shrouded in speculation, myths, and legends due to the region's tumultuous past, their presence and stewardship offer a glimpse into the rich heritage for which Yellowstone is renowned. Some believe that the spirits of these tribes still linger in the wilderness of Yellowstone. In the 18th century, this vast expanse was unknown to Euro-American settlers, save for a few Native Americans and explorers. Surprisingly, records show that Europeans ventured into these lands in the late 1700s. The famous Lewis and Clark expedition, undertaken from 1804 to 1806, significantly mapped these territories. While Meriwether Lewis led his group northward to explore the Marias River, William Clark, the skilled mapmaker and self-taught physician, guided his team southeastward to delve into the Yellowstone area. Although the expedition didn't directly venture into Yellowstone, it laid the groundwork for future explorations in the decades to come. Fast forward to 1869, when a group of non-Native Americans led by David E. Folsom embarked on the first documented expedition into what we now know as Yellowstone. Their modest journey marked the beginning of a wave of exploration from the Pacific to Europe. Subsequent expeditions, including the renowned Washburn-Langford-Doane expedition of 1870, followed suit. However, the most significant endeavor was the Hayden Geological Survey of 1871, spearheaded by geologist Ferdinand Hayden and sponsored by the federal government. This comprehensive survey meticulously explored Yellowstone and aimed to accurately document its breathtaking beauty. During the expedition, Hayden and his team, accompanied by artists, scientists, and photographers, spent several months meticulously studying and mapping the region. Their detailed records served as a cornerstone for future scientific endeavors and exploration. Their artistic depictions of Yellowstone's landscape became the earliest visual representations of its beauty. Finally, in March 1872, based on the conclusions drawn from these explorations, Yellowstone was officially designated as the world's first national park. Tales of tremors and turbulence. Each year, Yellowstone experiences thousands of small earthquakes, most of which go unnoticed by people. Throughout history, there have been 6 significant earthquakes, each with a magnitude of 6 or higher. One memorable event was the 7.2 magnitude Hebgen Lake earthquake in 1959, which occurred just outside the park's northwest boundary. The powerful earthquake shattered the Hebgen Dam and set off a torrent that flooded the land, reshaping the path of the Madison River forever. The quake's epicenter lay just beyond the park's western border. Suddenly, the ground surged like ocean waves in a tempest, unleashing utter chaos. Out of the turmoil rose Earthquake Lake, formed by the ruins of the Madison River Dam. Geysers, dormant for ages, burst into life, erupting in a rhythmic dance. Roads vanished beneath rubble, bridges buckled, and buildings crumbled. Yet, amidst the devastation, communities rallied together, rebuilding what was lost. Sadly, this event claimed the lives of 28 people. The area's vulnerability was carefully examined, leading to significant upgrades in safety measures, building standards, and emergency protocols. This quake stirred up a lot of talk among scientists. They think the stress it caused in the fracture zone might be why there's still earthquake activity in that part of Yellowstone. But not all earthquakes cause big trouble. Take, for instance, the 6.1 magnitude quake that hit the park back in 1975. It gave everyone a good shake, but thankfully, the damage was pretty minor. Then, there's this interesting phenomenon called an earthquake swarm. Imagine thousands of little quakes buzzing around like bees for 3 whole months in 1985. Scientists say it's all tied to the Yellowstone caldera, the giant volcanic crater beneath the park. Fast forward to 2007, and the ground under Yellowstone caldera was buzzing again with 16 small quakes in just a few days. These swarms are a bit like nature's way of stretching its muscles. In December 2008, things got even more interesting. Over 250 quakes rattled Yellowstone Lake in just 4 days, with the biggest one hitting a magnitude of 3.6. Then, in January 2010, another 250 quakes shook things up over 2 days. It's like the earth beneath Yellowstone never takes a break. The mystery of supervolcanoes. The Yellowstone caldera is like the king of volcanoes in North America, and it's a big deal worldwide, only beaten by Lake Toba caldera in Sumatra. People call it a supervolcano because it was made by huge, explosive eruptions. Underneath Yellowstone, there's this gigantic chamber of hot, melted rock. It's like a big underground lake of lava, about 37 miles long, 18 miles wide, and 3 to 7 miles deep. The caldera we see today was made by a ginormous eruption 640,000 years ago. It blasted out more than 240 cubic miles of ash, rock, and other volcanic stuff. To give you an idea, it was over 1,000 times bigger than the Mount St. Helens eruption in 1980. This eruption made a caldera nearly 1 kilometer deep and 45 by 28 miles wide. It also left behind this cool rock formation called the Lava Creek Tuff. The most intense eruption known happened 2.1 million years ago. It threw out a whopping 588 cubic miles of volcanic stuff and made the Huckleberry Ridge Tuff and the Island Park caldera. Then, 1.3 million years ago, there was another smaller eruption that spat out 67 cubic miles of stuff, making the Henry's Fork caldera and the Mesa Falls Tuff. Each time these monsters erupted, they covered a big chunk of North America in ash, messing up the weather and making life tough for some critters. Nowadays, scientists are keeping a close eye on Yellowstone because there's been a lot of shaking going on. Hundreds of earthquakes have been rumbling around there recently, making folks worried about another big eruption. A bunch of earthquakes happened between June and September of 2017, some even reaching a magnitude of 4.4. The real big question is where all this volcanic action is coming from. Some scientists think it's because of stuff going on in the Earth's crust and upper mantle. Others reckon it's deeper down in the Earth's mantle. It's a bit of a mystery because the Yellowstone hotspot popped up pretty suddenly in the geological timeline. And there's another curious thing. These big flows of lava, called the Columbia basalt flows, appeared around the same time and place as the Yellowstone hotspot. Some folks think they're connected somehow. As the Yellowstone hotspot moved, the Columbia disturbance followed along and then settled down. In 2018, a new idea shook up the world of volcano science. Instead of believing that fiery eruptions come from deep below, some scientists suggested a different story. They said maybe the volcanoes are fueled by watery bits from way down below, rising from the bottom of the Earth's mantle. These watery bits might come from pieces of an ancient plate, the Falon plate, slipping down from the Cascadia region. Others argued against the popular idea that a big hot blob in the mantle, called a mantle plume, is the main cause of Yellowstone's fiery bursts. They said the sinking Falon plate might act like a shield, breaking up the plume's power. So, even if some heat sneaks through, it's not enough to cause massive eruptions. Understanding the history of Yellowstone's volcanic past helps scientists guess when the next big blow might happen. But as always, predictions are tricky. Even with fancy tools like earthquake trackers and space maps, it's tough to see what's happening deep underground. Yellowstone's wild geothermal playground adds another twist. Sure, it's cool to study bubbling mud pits, but they can be a pain too. They like to spit mud at solar panels, cameras, and instruments, causing a mess and lots of cleanup. The park's natural gas emissions, like stinky hydrogen sulfide, don't play nice either. They eat away at metal instruments, worrying researchers who depend on them for gathering important data. And don't forget about the weather. Winter dumps heaps of snow, squishing delicate equipment and hiding solar panels. Batteries freeze up, leaving instruments powerless. Come summertime, lightning might zap radio towers, cutting off vital communication. Placing tools in the wilds of Yellowstone takes a lot of hard work. Scientists go on tough hikes, lugging heavy gear across rough land to get to faraway spots. This tough job is crucial for putting up and looking after equipment in places important for all sorts of research and keeping an eye on things. The energy and time spent on these missions show how dedicated scientists are to their work in this special place. Nature's hotbed of color. Every hour and a half to 2 hours, the Yellowstone caldera lets out hot water and steam, shooting them high into the air. This special rhythm of eruptions is a big draw for tourists. But that's not all. Inside Yellowstone's caldera, there's a whole array of hot springs, boiling pools, and mud flows. These natural wonders are powered by the heat escaping from the magma chamber beneath the Earth's surface, just a short distance down. As the water moves through the cracks in the rock layers, it warms up to more than 200 degrees Fahrenheit before bursting out, displaying stunning colors and textures. Among these marvels, the Grand Prismatic Spring stands out. The Grand Prismatic Spring is an extraordinary marvel nestled in Yellowstone, standing as the biggest hot spring in the United States and the third largest globally. Deep within its core, the spring hides water that's bubbling at a blazing hot temperature. However, as this water fans out, it gradually cools. In spring, vibrant hues paint the landscape, thanks to tiny living creatures called microbial mats. These mats, found near the edges of water rich in minerals, create a spectacle of colors ranging from lush greens to fiery reds. The intensity of these colors depends on the balance between two pigments, chlorophyll and carotenoids, and how hot or cold the water is. Come summer, the mats take on a warm palette of oranges and reds, while in winter, they sport a cooler shade of dark green. Interestingly, the middle of the pool remains devoid of color, heated to extreme temperatures. As for the deep blue hue at the center of the pool, it's all thanks to the natural color of water itself. This blue is most pronounced at the heart of the spring, where sterility and depth contribute to its fascinating effect. As visitors stroll along the boardwalk, they witness the amazing patterns akin to colossal flames, unaware that they're treading upon layers of heat-loving microbes known as thermophiles. These microorganisms, descendants of Earth's earliest life forms, revel in the harsh conditions of the Grand Prismatic Spring, stirring panic and uncertainty. As news of the recent swarm of earthquakes at Yellowstone circulated across the internet, social media platforms buzzed with chatter, ranging from speculation to deep concern and even apocalyptic predictions. People's thoughts and fears reflected a mix of anxiety and fascination with the colossal power of Yellowstone. Some users expressed their worries with dark humor, while others linked the seismic activity to global climate issues. Some feared that even if only a small part of the world was affected by a volcanic eruption, everyone would still be impacted by the ash-filled skies from sulfur showers. Amid this widespread panic, the U.S. Geological Survey and the Yellowstone Observatory stepped in as voices of reason and science. They reassured the public that while the earthquake activity was alarming, it didn't necessarily mean an eruption was imminent. Their words were grounded in scientific data and expert analysis, offering a much-needed perspective amidst the chaos. Yet, despite these assurances, the possibility of a catastrophic eruption loomed over the world. Another major concern was the potential for eruptions in the park's lakes, events that have historically sent shockwaves around the globe. Yellowstone Lake, for example, stands as North America's largest body of water and the world's second largest at such a high altitude. It's a hub of life, nourished by numerous streams and rivers, including the mighty Yellowstone River, which flows into the lake from the southeast and exits at its northern tip. With an average depth of 140 feet and a maximum depth reaching around 390 to 410 feet, Yellowstone Lake boasts impressive dimensions. It's not just its size that's fascinating. The lake features distinctive characteristics that make it unique. Split into two branches, the southern and southeastern extensions resemble fjords, stretching beyond the oval-shaped main body of the lake. On the lake's western side lies West Thumb, a button-like formation formed by a modest eruption of the caldera approximately 150 years ago. The hydrothermal wonders of West Thumb Geyser Basin, Yellowstone's oldest, were first documented in 1827 by a Philadelphia newspaper. Teeming with life, Yellowstone Lake hosts a variety of waterfowl, including Canada geese, diverse duck species, American white pelicans, and the elusive trumpeter swan. Monitoring Yellowstone's seismic symphony. When it comes to volcanic eruptions, paying attention to the sequence of earthquakes can give us valuable clues. While different seismic events might hint that an eruption is on the horizon, the real warning comes from continuous monitoring efforts tasked with keeping an eye on Yellowstone's seismic and volcanic activity. Various organizations, including government bodies, research institutions, and park management groups, work together to assess the risks posed by Yellowstone's volcanic system. Leading the charge in alerting the public about potential disasters are the Yellowstone Observatory and the U.S. Geological Survey, USGS. These agencies do an impressive job of documenting all seismic activity in the area. The University of Utah Seismograph Stations is like the detective agency for Yellowstone's volcanoes. They've scattered special gadgets called seismometers all around the area. Their job? To catch any whispers or rumblings from the earth that could mean a volcano is about to wake up. These scientists have a plan, and it's a big one. They've split their detective work into two main parts: nuclear snooping and hydrothermal monitoring. Nuclear snooping involves using clever gadgets like GPS receivers to spy on any tiny movements in the ground. By watching these sneaky shifts, scientists can tell if a volcano might be stirring. Then there's hydrothermal monitoring. Think of it like keeping an eye on Yellowstone's bubbling hot springs and steamy geysers. These spots are like little windows into what's happening deep underground. By watching the temperature, chemistry, and gases bubbling up, scientists can tell if the volcano's getting restless. But the detective work doesn't stop there. These scientists are always looking for new tricks to improve their volcano vision. They're dreaming up ideas like flying drones with special heat cameras or teaching computers to spot volcano clues in real time. The future is full of possibilities. Of course, it's not all smooth sailing. The scientists face tough challenges ahead, from trekking through wild and rugged terrain to keeping all their gadgets up and running. It's no easy task. And even with all their fancy tools, predicting when a volcano will blow its top is still a bit of a guessing game. But these detectives are up for the challenge, because the safety of Yellowstone and its visitors depends on it. These tireless professionals devote their lives to monitoring geological activity, acting as guardians during uncertain times. Their commitment was particularly evident following the Maple Creek incident of June 12, 2017. On a beautiful day in Maple Creek, under the bright sun and fresh air, a sudden disturbance jolted the tranquility. What started as a gentle tremor escalated swiftly, shaking trees vigorously, similar to scary scenes from a suspenseful movie. The town's residents, taken aback by the unexpected event, quickly realized something was amiss. Investigations into the cause revealed heightened seismic activity stemming from geological movements beneath the town, prompting urgent safety precautions. Meanwhile, scientists directed their attention to Yellowstone Lake, closely monitoring seismic events in the area. Analyzing data spanning from 1983 to 2008 revealed intriguing findings. Among the 250 earthquakes recorded, the most powerful tremor, measuring a notable 3.9 on the Richter scale, originated from the lake. Yellowstone's lake region serves as a crucial focal point for tracking seismic activity across the park. Although scientists remain puzzled by the lake's unique seismic behavior, their primary concern revolves around the looming threat of a potential eruption. Consequently, efforts are concentrated on implementing necessary safety measures to mitigate potential risks and safeguard lives. A representative from the U.S. Geological Survey assured the public of the unlikely prospect of an imminent eruption, citing the current seismic activity within the park. However, it's essential to acknowledge the inherent uncertainty of forecasting geological and geothermal events with absolute certainty, despite the reassurances provided. Nature's twists and turns can catch us off guard, morphing into unexpected shapes and routes. The job of the U.S. Geological Survey and the Yellowstone Observatory is to spot these changes early and warn folks, giving them a chance to stay safe without disrupting the natural flow of things. By staying proactive and spreading awareness, these organizations help prevent loss of life and minimize the risks posed by geological hazards. Now it's time for today's subscriber pick. In the heart of Yellowstone National Park, where geysers hiss and wildlife roam, a sense of unease ripples through the air. The earth trembles, and hundreds of earthquakes shake the ground, rattling the nerves of visitors and park officials alike. Amidst the chaos, Ranger Claire stands at the edge of a bubbling hot spring, her brow furrowed with concern. As the park's chief geologist, she knows the signs all too well. With a heavy heart, she gathers the park staff and issues a serious warning. Her voice echoes through the trees as she addresses the gathered crowd, urging them to heed the danger lurking beneath their feet. She explains the potential for a catastrophic eruption, one that could devastate not only the park, but also the surrounding communities. As the Yellowstone official gives serious warning, after hundreds of earthquakes hit the national park, fear grips the crowd, but Ranger Claire doesn't falter. Instead, she offers reassurance, reminding them of the resilience of nature and the importance of preparedness. Together, they formulate evacuation plans and distribute emergency supplies. As the sun sets over the majestic landscape, Ranger Claire stands tall, a beacon of hope in the face of uncertainty. For in Yellowstone, amidst the turmoil of earthquakes and warnings, there remains a steadfast resolve to protect and preserve this natural wonder at all costs. Do you think the quakes are a sign of imminent eruption? Yellowstone. Unleashing catastrophe. Imagine if the Yellowstone supervolcano decided to blow its top today. Here's how it might play out. Deep down in the Earth's belly, heat would start melting the rock just beneath the surface. This molten mix would brew, gathering magma, rocks, vapor, carbon dioxide, and other gases. As pressure builds up, the ground would swell into a dome, cracking along the edges. When that pressure finally bursts through the cracks, the dissolved gases would explode, spewing magma across the park in a fiery rush. But it wouldn't stop at dangerous lava flows. The eruption could claim up to 90,000 lives instantly and blanket areas up to 1,000 miles away with a 10-foot layer of searing ash. Rescuers would face a daunting task, with ash blocking all ground routes and grounding most air travel, just like what happened during Iceland's volcano in 2010. Yet the aftermath could be even more chilling. Experts warn of a potential nuclear winter, where sulfuric gases released into the atmosphere mix with water vapor, covering the country in a haze that dims sunlight and cools temperatures. This drop in temperature could wreak havoc on crops, disrupting the food chain and echoing the fallout seen after the 535 CE eruption in Java. While the chances of Yellowstone blowing its lid are slim, only about 0.014% each year, scientists are still keeping a close watch. The magma chamber beneath Yellowstone's caldera is only partially molten, which might limit the scale of future eruptions. But what about other supervolcanoes? With their potential for catastrophe, they too keep scientists on edge, ready for whatever Mother Nature may unleash. Take the Long Valley caldera in California, for example. The The volcanic story of the Long Valley caldera area began millions of years back when magma started gathering miles beneath the ground. The volcanic action became concentrated around what's now Long Valley caldera about 3.1 to 2.5 million years ago, with eruptions of different types of volcanic rocks. Over time, a group of mostly rhyolitic volcanoes formed in the area, covering around 1,500 square miles with lava flows. Almost all of these volcanoes, except for Glass Mountain, were wiped out by a massive eruption around 760,000 years ago. This eruption spewed out an immense amount of material, reaching as far as Nebraska and Kansas. Initially, the eruption created a deep caldera, like a huge bowl, about 2 to 3 kilometers deep. But a lot of the material was thrown straight up, fell back down, and filled the caldera up to about 2/3. Nowadays, the caldera is a vast depression, about 20 miles long, surrounded by mountains, except on the southeast side. The bottom of the bowl sits at an elevation of 6,500 to 8,500 feet higher in the west. In the middle, there's a dome pushed up by magma, while the southeast slope is filled with solidified ash called Bishop Tuff. The caldera's rim is made of existing rock, rising about 3,000 feet above the caldera floor, except for the lower eastern rim. Mammoth Mountain, a complex of lava domes, sits west of the rim, reaching 11,000 feet in elevation. Along the western edge of the caldera, there's a 25-mile-long chain of volcanic craters, called the Mono Inyo craters, extending from Mammoth Mountain to Mono Lake. The Mono Inyo craters burst forth with fiery explosions, blazing a trail of eruptions ranging from about 40,000 years ago. The geological forces behind the volcanic activity in the Long Valley area remain a mystery, fueling ongoing research endeavors. Unlike Yellowstone's fiery heart or Hawaii's volcanic chains, Long Valley's genesis isn't tied to a hotspot or subduction. Instead, its volcanic history stretches back millions of years, with magma lurking beneath the surface. Nature's early warning system. Yellowstone is like a paradise for big animals in the lower 48 states. With nearly 60 different kinds of mammals calling it home, it's like a bustling city for wildlife. Picture majestic creatures like the Rocky Mountain wolf, coyote, and even the elusive Canadian lynx roaming around. But that's not all. There's a whole lineup of other big guys too. The bison, often called buffalo, strutting around like kings of the park. Yellowstone's bison herd is like a bustling metropolis all on its own, the largest of its kind in the country. Once upon a time, bison roamed North America by the millions, but now Yellowstone is one of the last places where they can still be found in large numbers. It's like a living museum, preserving a piece of our wild past. From just a handful in the early 1900s, their numbers have bounced back to over 4,000 strong by 2003, a true testament to the park's dedication to conservation. New studies have uncovered an intriguing link between the behavior of Yellowstone's bison and what's happening beneath the surface of Yellowstone Lake. Before earthquakes hit, these mighty herds start acting a bit differently, like becoming restless and moving away from areas where the ground is getting more active. These changes in how they act could be like nature's way of giving us a heads up about possible volcanic activity. It's like the animals are sensing something big is about to happen before we do. By keeping a close eye on what the bison are up to, scientists can learn a whole lot about what's going on deep underground. Understanding this connection between animal behavior and what's going on beneath the Earth's surface isn't just about Yellowstone. It's about protecting our world from the effects of volcanic eruptions, which can cause chaos for both wildlife and people. From messing up ecosystems to changing how animals find food, volcanic activity can shake things up in ways we're only just starting to understand. But if we pay attention to what nature is telling us, we might just be able to get ahead of the game. By combining what scientists know with the wisdom of nature, we can come up with smart ways to keep everyone safe from the dangers of volcanic eruptions. Yellowstone Park serves as a powerful reminder of how delicate the balance of life on Earth really is. And while it can feel overwhelming, there are people out there working hard to keep us safe, even in the face of uncertainty. What do you think about the possibility of a volcanic eruption at Yellowstone? Let us know your opinion in the comments below.